Now we're going to use our previous trick of recurrence to demonstrate what's usually called the reduction formula for the integral of sine to the nx or the integral of cosine to the nx in the case of sine to the 5x. So to integrate sine to the 5x using integration by parts, I'm going to split off one sine value. So I'm going to let u equal sine to the 4x and dv is sine x dx. I can easily integrate dv, and certainly u becomes a little simpler when I differentiate. So du using the chain rule is 4 times sine cubed x by cosine of x dx, and v is the antiderivative of sine, which we all know is minus cosine. Plugging this into our formula, we get the integral of sine to the 5x, which is sine to the 4 times sine of x dx, is minus cosine x times sine to the 4x, that's u times b, plus 4 times the integral of cosine x times sine cubed x by cosine x dx, which is minus the integral of v du. And tidying up a little bit, this is minus cosine times sine to the 4x plus 4 times the integral of cosine squared of x times sine cubed of x. Now the thing about cosine squared, which is often very useful when you're integrating, is you can rewrite it in terms of sine squared. So cosine squared of x is 1 minus sine squared of x. And substituting that for cosine squared in the integral on the right means we can break up this integral. It becomes sine cubed of x minus sine to the 5x, and we can break it up into two simpler integrals. So now we have the integral of sine to the 5x dx on the left equals minus cosine x times sine to the 4x plus 4 times the integral of sine cubed x dx minus 4 times sine to the 5x dx. So notice our integral on the left is popping back up on the right again. So we can use recurrence here, but we also have the integral of sine cubed on the right, which we haven't talked about yet. Well, highlighting the integral of sine to the 5x dx on both sides of the equation here, that's our unknown variable. So let's call it I and try to solve for I. So we have I is equal to minus cosine x sine to the 4x plus 4 times the integral of sine cubed x dx minus 4i. Now notice we haven't integrated sine cubed x dx. We'll talk about that a little later. Solving for I, we bring all of the terms with the i's to the left and everything else to the right, and we get 5 times I equals minus cosine x times sine to the 4x plus 4 times the integral of sine cubed x dx. And the integral of sine to the 5x dx, which is I, dividing the above equation by 5, is 1 over 5 times cosine x times sine to the 4x plus 4 times the integral of sine cubed x dx. Now, the important part of this formula is that we haven't completely worked out a function which gives us the integral of sine to the 5x dx, but we've reduced that integral to a simpler integral, which is the integral of sine cubed x dx. And using exactly the same methods, you can reduce the calculation of the integral of sine cubed to an expression involving the integral of sine, and you can always reduce this power of the sine by 2 using integration by parts. So this is called the reduction formula for the integral of sine to the n, because it means that you can simplify the integral, you can reduce the power by 2, and you can continue doing that and solve your integral in several steps.